Now we turn to dimensional tables and then bring both fact tables and dimensional tables into a complete dimensional model on next couple of slides. So dimensional tables give the measurement facts their meaning and interpretation. Each row in a dimension table starts with a surrogate key auto-generated during the ETL process, which serves as primary key for the dimension table and is inserted as a foreign key into the fact table. This way, surrogate keys serve as direct links between dimensions and fact tables, as we described before. Following the surrogate key is a list of preferably verbal attributes describing this dimension, such as, Wednesday for weekday, April for month, Q2 for the quarter, yes for workday, no for holiday, 2029 for the year, etc. Product name, brand, subcategory, category, and group would be some of the typical product dimensions. Store country, state, city, and zip code might be some of the geographical store dimensions. All of these dimensions are used as query constraints, groupings, and report labels. The store profitability might be reported by country, grouped by city, restricted to certain product brands, and for a specific month of a specific year. The more verbose these attributes are, the easier it is to formulate the queries and interpret their results. Dimension tables tend to have natural hierarchies built into them for drill downs, such as year, down to month, down to week, down to day, and roll-ups such as product name going up to brand, then subcategory, then category, and then the product group. These tables tend to have relatively few rows, especially when compared to millions and billions in fact tables, but many more columns. It is precisely the richness and descriptiveness of these attributes in hierarchies that allows for more meaningful queries and analysis of the data. So, at this point, we are ready to put the two together. The fact tables. The fact table is typically a single one plus multiple dimensional tables. The simplest and most elegant dimensional data model is the Kimball star schema with a single fact table in the middle, right here, surrounded by multiple dimensions, each of which is directly connected to the fact table only. Finding total sales right here for female customers right here, okay, in a given state, that's someplace here as well, okay, during a specific time period based on this dimension, under particular promotion down here across several stores in the same state, okay, for a specific brand of product right there, is easy to formulate, visualize, and understand. This is the simplicity and the power of the star schema as illustrated on this retail data mart. Although Kimball continues to preach the simplicity of his dimensional star design and urges data modelers to resist normalizing dimensions, some degree of it is considered acceptable in today's data warehouse design. Especially for designers coming from the operational world, it is often too difficult not to attempt to normalize some dimensions such as product and product class here, as well as store and region dimensions indicated on this slide, or the variation of the retail scar schema from the previous one. Once you introduce so-called snowflake dimensions such as the region here or the product class, you realize that the customer dimension can be normalized as well, right here, okay, and pretty soon, okay, if one is not careful enough, the dimensional model, this whole thing here, starts looking more and more like a cobweb spaghetti design of an operational system ERDs. Okay, so unless there is a real and compelling reason to do so, snowflaking a dimensional model is not recommended. Okay, it increases presentational complexity, and because of the increased number of joins, it negatively impacts query performance, thus going against both principles of solid dimensional design, which is the simplicity and the fast query performance. Keeping the highly denormalized design, like the one 2 slides ago, makes it simpler to understand, work with when designing queries, faster to run those queries, and then easier to interpret the results. So this slide shows the snowflaking of the product dimension down towards the bottom, as opposed to, or versus, keeping it denormalized in the top right corner of the slide. Okay, and before going into our order management dimensional model, this is a good place to pause.